So in this case, with a pendulum, we're going to have the energy swapping out between potential and kinetic. So let's just take a quick look here. So our pendulum is going to swing, and if this is the top, it's going to swing over to this way and end up over here. And then it's going to turn around and start swinging back. And so what we have going on here is it's like throwing a ball up into the air. Eventually it comes to a stop, and as it's changing directions, it passes through velocity of 0 at the very highest point. And that's what's happening here, is at this very highest point, it passes by velocity of 0. And that we could determine later is where the potential energy is really high. And then as it starts swinging down again and heading in the other direction, it goes down, and at the very bottom we have our maximum velocity. And so we're told in the question that the maximum velocity is 5 meters per second. And then it carries on and slows down until it gets up to 0 again and turns around and starts heading back. So there's our scenario there. So this would be our maximum kinetic energy, and this would be our minimum. And we could also say this is our minimum as well, because it goes back to 0 on either end. So let's see what we can determine here. So for the minimum kinetic energy, the energy of motion, 1/2 mv squared, but we know right away that we do have a mass for sure, but we know that the velocity is 0. 0 squared is 0, and 0 times anything is 0. Bottom line is we have no kinetic energy at the minimum point. At the maximum point, at the very bottom there, where it's swinging at its highest speed, EK, 1/2 mv squared. And in this case, we have the mass will fill in 0.25, and then we have our 5 squared, and we can put that into our calculator, and with a little rounding, 3.1 joules. So there's our maximum kinetic energy, and again, that's at the very bottom. Maximum kinetic energy means that this particular object is going at its highest speed, and we're all done.